Welcome back to the series where I am doing a comparison of using Unity's visual scripting and C#. This series is aimed at Unity newcomers who do not yet know which scripting method to use for their games. This is the second video where I'm creating a game of Pong using visual scripting and C# and doing a comparison between them in the same video. To view the whole series, the link to the playlist is in the description. Okay, let's continue with creating our game of Pong. So the first thing I want to do is just make a few changes to the camera. This is essentially a 2D game that I've created with 3D objects. So let's just make this a bit easier for ourselves. Click on main camera and switch projection from perspective to orthographic. That basically changes the camera to ignore depth, which is fine for our, what kind of a game you call this? I think they call it a 2.5D game. And here, instead of having to move the camera back and forth, what you can do is just change the size. And if you look here at the preview area, you will see your pedals come into view. And just move your camera along to the left or right, just dragging on the X and Y values to align it to the center. And that looks fine to me. I'm going to save that. And what we can do in the scene view is also switch to orthographic mode, and you do that by clicking this little square in the middle of your rotation gizmo at the top. So if you switch to that little square, you will see it's kind of just ignores your depth in the scene, and that will make things easier for us going forward. Okay, now we need some bounding boxes, and we're going to just use 3D objects for that. So click on 3D object, cube, and move this to the left. Okay, I actually, I think I switched that back to perspective instead of orthographic mode. Okay, so let's resize this. So I'm going to change the scale on the y-axis to make our left wall. Control D, duplicate that and move it to the right. I think that looks good. Let's just click on our camera and see the preview. Click on game. You can't really see the walls. So this might be a better way. Just click on your game view and align it. So click on cube and just drag left and right, or a bit to the right to bring that into view. Click on your second cube and again click and drag on that X position, bring that into view. And let's click on our main camera and scale it up a bit. Okay, no, actually I'm going to undo that. Leave it as it was. What I want to do is resize that cube. So you can select both of them and then just scale the y-axis down. So I'm going to click and drag on scale Y. Click and drag to the left to scale it down. And realign it with the position Y, dragging left and right, and that seems to be okay. Going back to scene view, and what I'm going to do now is create the top and bottom walls. So right click 3D object cube and drag that up. So what I'm going to do here is just snap this cube. So remember, you can use your right click to rotate in your scene. Click on your cube and hold V to grab a corner. If you guys are not familiar with this or very new to Unity, consider looking at some of my earlier videos where I go through all of this. Getting used to the editor and showing you guys a lot of nice shortcuts. Okay, so I'm going to drag that to the right and scale that down again. So it's a bit difficult to scale and move things sometimes in Unity, especially just using the basic primitive types. So okay, what do I want to do? I want to change the y, change that back to 1. Okay, that's now moved it off again. Just need to keep realigning that. And it doesn't have to be 100% perfect. This mustn't be noticeable. I think that looks okay. Control D, duplicate that. Click, press W and move this down. W is a shortcut for changing to your transform tool, your move tool. Hold V, grab a corner and snap it to the other corner of the left wall. And what does that look like? That looks okay, I guess. Is that sticking out at all? If it is not noticeable, I think that's okay. Click on game view and okay, the wall's a bit high. Actually no, that's okay because our ball's going to be bouncing along here. What we can do is actually, you know, just leave it. If you guys want to be more thorough with your game, go for it. I'm just going to leave it at that. I think it looks okay. You see, as I rotate around, you'll see my pedals are not in line with my wall, so we need to change that. And I'm going to select with both of them selected, player 1 and player 2. I'm going to set Z to 0 and set our cubes as well, the Z value to 0, and that will line them up. So now if I check, okay, they're all lined up properly, and that is very important. Otherwise your ball and pedals are not going to collide, and your ball and the walls are not going to collide, and you're going to be wondering what on earth is going wrong. I'm going to create an empty object and call this walls and drag my cubes onto that. Okay, so those are grouped nicely. Let's get back to our player script. Move pedal. Now, if I press play, I want you to notice something. If I move up and down, my pedal goes through the wall, even though there are colliders on the pedals and the walls. You can double check that. I'll show you. So with my player 1 selected, you'll see I have a box collider and my walls have colliders as well. So what's going wrong? Well, here's the thing, and this is something I mentioned before. The problem is we are using translate, and if we are going to use translate, we are going to have to add some calculations to check that we are not going past the bounds of the walls, which is going to be a bit of a mission. What we can do is actually take advantage of Unity's built-in physics engine to do that for us. Okay, so in order to get physics working and make sure our pedals don't go through the walls, what we have to do is add something called a rigid body. I'm going to select both of my players, add component and rigid body. If you have decided to do this project in 2D, just make sure you have selected rigid body 2D. And what I'm going to do here is untick use gravity, and I'm going to freeze rotation on X, Y, and Z so that my pedals don't go spinning off in all directions when it hits something. If I press play now, it's still not going to work, and the reason is using translate ignores physics. So what's happening here is I'm moving the pedal at a fixed distance every single frame. And during that time, it could have gone through the wall, and it doesn't check beforehand, hey, there's a wall in the way, so don't actually move. In order to do that, we need to take advantage of the physics functions. Now to do that, we'll have to change our script. I'm actually glad I did it. So this was a mistake on my part. I should not have used translate to begin with. But now we can see how to go about changing things and refactoring. Like I mentioned in the last lesson, refactoring is part of the business. So I'm going to delete the translate just under player 1 for now. That's the first F, the true bit, and I'm going to grab the output of get access. And what we need to do is create a new vector 3. Okay, I'm just going to search for vector 3. Vector 3, you'll see there's a little arrow on the right. Just click that, and we want to create vector 3 with this third one, X, Y, and Z, or even X and Y will work, but I'm used to the third one. And what we can do here is take the multiply output and pipe it through to Y. And that creates for us a new vector, which we are going to pass into our rigid body. So from here, on rigid body, we're going to set a velocity. So set velocity. Okay, rigid body dot. Click on the arrow on rigid body and look for the set velocity. There. And we can take the output of this create vector 3 and pipe it into there. Okay, so save that, and before we press play, you want to go to object and change move speed. So move speed, we had to decrease that when we were using translate, but now for set velocity, we need to actually increase that. So I'm going to set that to about 10. Let's see what difference this makes. Okay, let's increase the size here. Okay, so it's moving fine. And as soon as I hit the wall, it stops. Brilliant. Okay, players 2 is still going to move through. So let's change that. Same thing. Remove translate. I'm going to duplicate these. F to Y. Connect input access to create vector 3. And I think that's okay. Okay, now it's not moving. Player 2 is not moving. What did I do wrong? I don't see any problems. Everything seems to be connected fine. So why is this not moving? Just check that again. So you can see the values that's being output here. I don't think I showed you guys this before. So if I press up and down, ooh, the second part of my if does not seem to be working. It's not getting in here at all. It's getting to my first bit. Oh, my is player 1 is not set for player 2 by the look of it. Oh, okay, so I had player 1 and player 2 selected, so that was a bit silly. Let's just have player 2 selected and see what that gives us. Okay, now we see it going through to player 2. So this is definitely where visual scripting is better than C#. You can see where your flow of execution is going so easily. You can't do that so easily with C#. And okay, so if I press up and down, I can see values here. Let me just zoom in. I'm zoomed in max. So the values here, X, Y, Z, is being set to 1. It's just not, oh, I did not set a rigid body on my second one, did I? I did. It's my move speed. Move speed is still 0.1. So I need to change that to 10. Now this should work. There we go. Both are moving fine, and stop at the walls. Brilliant. Okay, let's see how we do this in C#. By the way, I'm going to get rid of this mess in the next lesson. I'm going to show you guys how to use super units to reuse code so that you don't have to, I'm calling this code even though it's visual scripting. I'm going to show you guys how to reuse logic in your scripts so that you don't have to go and duplicate, because this is such a mess. You saw that when I had to change something for player 1, I had to go and do the exact same thing for player 2, which is just a waste, and it is definitely not the way to go about designing your programs, whether it's visual scripting or C#. Okay, now onto C#. Okay, so easy way to do this, I'm going to select my walls, copy it, just make this scene saved, and go to my C# scene, and I should be able to paste this. Ah, great. Okay, so I just pasted the walls in from my other scene, and I'm going to adjust that a bit. I'm going to make the same change I did to my camera, which is changing from perspective to orthographic, resizing it. This looks fine. Okay, just press play. Okay, that's looking fine. Just adjusting my view here because something just does not look right. Okay, there we go. I need to move my player 1 a bit to the right. And I'm just eyeballing it. It looks about right. Okay, scripts. Move pedal. I'm going to open up Visual Studio, and what do we need to do? Add rigid bodies. Rigid bodies to my player 1 and player 2. Add component, rigid body, untick, use gravity and freeze rotation. And I did that with having player 1 and player 2 selected. Remember, to select 2 objects at a time, you can hold down Control or hold down Shift and click. Okay, Control and click just selects individual ones, and Shift click will select multiple from where you start into where you click end. Okay, so it will select everything from directional light to scene variables if I hold Shift and press click. Okay, anyway, just a small tip. Okay, rigid body. I need to get my rigid body. I'm going to do that before this if, so I only need to get it once. And rigid body. Rigid body is the class name, and I'm getting the component of my game object. So rigid body is equal to get component. In this weird syntax, this is called generics, but don't worry about that too much. Just know that if you need to get a component of something, whether it's a rigid body, collider, another script, whatever it is, you use this get component and this diamond brackets. And in here, I'm putting in rigid body. Then round brackets afterwards and semicolon. Remember, if you are following along, have everything typed out exactly as it is. Just after this curly bracket, case sensitive, uppercase where it needs to be, lowercase where it needs to be, and you'll be fine. Otherwise, you will get an error. Okay, so now I've got the rigid body. Instead of translate, I'm going to remove that in both places. What I can do is rigid body dot velocity equals new vector 3, and we are only moving on the y-axis, so x will be 0, y will be move amount, and z will be 0. Okay, I'm just going to test it with player 1 for now. Let's see if this made any difference. So for player 1, I'm setting move speed to 10. Well, let's just do it for both players while we're at it. Move speed 10. Now you should stop at a wall, and you did not. I think my player and my walls are not lined up properly. They are not. Okay, so I'm setting player 1 and player 2 Z to 0, and that should work. Great. That works so well. Okay, player 2, I need to add the code in to change that. And okay, one thing we can notice here is we are repeating code for move amount. That's pretty much the same. The only difference is this move amount we're getting it from either vertical or vertical 2. Okay, so I'm gonna cut that code out and only leave that in and move that code to the bottom. So, and I need to move this variable declaration to the top. Otherwise it complains. Because I need to move this move amount at the bottom as well, I need to move the declaration for that variable. Otherwise, that variable can only be used inside here if I had it how it was before. Over there. Okay, so variables are limited to scope, but we'll get to that later. What's important to know now is move amount. We're setting it to 0 initially. Set it to vertical axis, and we update it with the speed. Why is it grayed out? That's what's worrying me a bit at the moment. When it's grayed out, it usually means that variable is unused, so I don't understand why it's grayed out. Maybe it's just Visual Studio that's a bit weird. Okay, so player 1, player 2, they're both hitting the walls fine. Perfect. Now, in the next lesson, we can add the ball in and get that moving around. And here I will definitely say that C# is the winner again for the simplicity of code. But like I showed you guys earlier, I'm just going to save this, go back to my visual scripting scene. This bit of visualizing the flow of your code with visual scripting is just awesome. Being able to see, okay, it's going to update, then if, then from false into, and just carrying on up until you set the velocity. That is just awesome. I really enjoy this about the visual scripting. But then again, getting to where we are here is just a lot more cumbersome than doing it in C#. So yeah, I will give this to C# again. I'm going to get rid of this little group that just stay in the middle of nowhere. Okay, until next time, enjoy.